What color do you think the dancer's dress is? Somebody will say without hesitation red, but there are people who will argue furiously that it's scarlet or coral. Scientists came to the conclusion long ago that we see colors differently. It's all about our brain, an organ where visual information is processed. More exactly, how it interprets images, depending on lighting and even our mood. Imagine that we can see the world around us not just a few color shades brighter, but a completely different way. For example, the way a synesthete like Synesthesia would, or like Yevgeny, who has very sharp eyesight, and finally like our third participant, Edouard, only with the help of echolocation. By nature, these three perceive the world in unique ways, and they're ready to prove it to our experts. On our jury today, Pavel Balaban, neurophysiologist, professor, DSc, PhD, biology. Corresponding member of the Russian Academy of Sciences, RAS, head of the Institute of Higher Nervous Activity and Neurophysiology at the RAS. Anton Sidorov-Dorso, senior teacher at Moscow State Pedagogical University, psychologist, synesthesia phenomenon researcher, co-founder and member of the International Association of Synesthetes, People of Art and Science. And finally, Grigory Kamenkarov, DSc, PhD, biology, head of the Laboratory of Neurochemistry at the Institute of Biochemical Physics, Russian Academy of Sciences, RAS, an expert in the field of molecular and sensory physiology. Right now, we'll find out what our experts think about Synesthesia's unusual ability. She perceives the world as being much brighter than most of us do, because every number, letter, word, geometric shape, and even sound that Synesthesia perceives is associated with certain colors in her head. Synesthesia didn't realize for a long time that her perceptions are specific and unique. Until the age of 11, she was sure that others felt the same.
I was talking with a friend and told him that his name is Yellow. Anton is a yellow name, and that's quite logical. Maybe you can have some associations as well. He answered, "No, that's a little strange. What do you mean?" I told him, "Why Tuesday is blue, for example. What's wrong?" He answered, "No, I can't understand what you're talking about." I thought, well, that's strange.
Synesthesia found out later that synesthesia, a rare and poorly studied neurological phenomenon, is responsible for her wonderful color perception of the world. The phenomenon, synesthesia, derived from the Greek synesthesias, is determined in psychology as a perceptual phenomenon in which stimulation of one sensory or cognitive pathway leads to automatic, involuntary experiences in a second sensory or cognitive pathway. To put it simply, due to stimulation of the cerebral cortex, a synesthete is able not only to hear sounds but also to see them, not only to feel a thing by touch, but also feel its taste.
First of all, I have strong responses to numbers, letters, and sounds, namely music, voices, and even weak sounds. Recently, probably a year ago, I realized that I have a synesthetic response to shapes and lines. I mean that if I focus my attention on, let's suppose, I see something round and I think that it looks like a circle, I see the color of the circle.
It's quite difficult to believe that there are people who perceive the world like Synesthesia. You can't help but doubt. What if it's all the result of a fertile imagination? We'll find out right now.
Hello, my name is Synesthesia.
Hello. The first test will be as follows. You'll have to determine the color of letters which appear on the screen.
I see.
And the color of these letters won't match your colors.
I see.
Are you ready?
Yes.
The first letter, please.
Violet, Red.
Next one.
Green.
If every letter in Synestesia's head really has its own color, it takes her some time and additional effort to adjust and name the true color of each letter. However, it seems that our participant doesn't find it difficult and answers without mistakes. Well, let's make the test more difficult and add some more symbols, and in some cases, a color background as well to each slide.
Black.
Background.
Yellow.
Next one.
Gray. White background. Violet. White background.
Next one.
Blue and green.
Next one.
Bright green background. Black and brown.
Next one.
Oh my gosh. Bright green and violet background. Blue and bright green.
Next one.
Orange and black.
Next one.
Red background, white and black.
Well, Synesthesia made some mistakes at last, but did she notice them?
Synesthesia, how difficult was this test for you?
Well, sometimes it was uncomfortable because I couldn't decide what to choose, a letter or a color.
And at some point you had an unusual emotional response. Why?
Oh my gosh. It's just that there were a lot of colors and it was difficult.
May I ask you a question?
Sure.
Synesthesia, do you think you did that without mistakes? Maybe you made a few mistakes.
I'm not sure. Probably I made some, but I did my best.
Can you remember where you made them? What color, in your opinion, did you name wrong?
Well, not exactly. Well, I had a controversial moment with the gray color.
Well, that's understandable. Gray is not a
probably
color.
with the blue letter E, because it looks violet. But frankly speaking, I'm not sure what color it was.
Well, look, gray is kind of no color at all, right?
A gradation.
This is white and gray. Gradations, right. You recognize the gray color on the white background. That means that you perceive brightness differently and nothing more.
Yes.
Could you tell me what colors are the most difficult for your recognition?
The most difficult are colors which I associate with other letters or numbers. I mean, similar shades which usually don't go with these letters. Unusual colors that I don't have, I see at once. For example, the bright color green usually doesn't match any letter or number, or it's very rare. As for orange, red, or yellow colors, or dark green, it's much more difficult.
It seems that the obstacles that Synesthesia faced when performing the task and the mistakes she made show that she has so-called colored grapheme synesthesia. The experts decided to carry out another test to see how unusual this is.
During the test, you'll see a rectangle made of two types of numbers. The first type forms the background, the second one, the figure. You'll come up to the screen and point out the figure that is coded in this rectangle as fast as possible.
I see.
Do you understand the task?
Yes.
Please come up to the screen. Ready?
Yes.
Let's go.
The experts suppose that Synesthesia will recognize all 2s on the background of 5s very fast. The experts were right. In her head, 5s, which form the background, are the color red, and 2s, which form the figure, are blue. Now, Synesthesia sees these rectangles this way. Well, let's make the test more difficult.
It's more difficult with these numbers. They have quite similar colors.
Below you can see Synesthesia's whole corresponding palette for colors and numbers. Take notice that in her head, 9s are black and 6s are dark brown. In other words, that's approximately what she can see now.
I don't understand what it is.
Can't you say?
No.
Answer, please.
Well, yes.
Yes, next one.
Are you kidding? Well, okay. 9, 9, 9, 9, 9, 9.
Answer, please. Perfect. Next one.
No sooner had the experts changed the number pairs than her speed and effectiveness of the figure's recognition increased again. That makes sense because it's obviously easier to distinguish yellow 3s on the background of bright green-violet 8s. All in all, Synesthesia made 2 mistakes in the second test. It happened when she was working with rectangles made of 9s and 6s. Probably the black and brown colors merged in her head, which made the recognition more difficult.
Colleagues, I think Synesthesia recognized all of the figures very fast, but she made mistakes. I think it would be important to compare this result with the response of a control subject, an ordinary person. Can we do that? Yes, a control subject.
Anton, a volunteer who has no synesthesia, now he has to take the same test. Let's see how fast that he can see the coded figures. It took Anton 40 seconds to show the first figure to the experts. After he sped up a bit, he spent about 20 seconds on every new task with 5s and 2s. In some cases, he coped with tasks even faster. However, no sooner had the experts changed the number pairs than the speed at which he recognized numbers decreased dramatically.
Everything here is broken down.
Good. The answer, please.
It's quite difficult, as if everything is separated.
Very interesting. A big difference. Yes, there's a difference, but in general, Anton would still recognize all of these figures without color perception. No wonder, yes. But the execution time is important. Yes. It's obvious that there's an automatic selection in Synesthesia's head. The control subject has no such selection. Yes, it's important that he acquire the skill during the test. I mean, he performed the first test slowly, and then he performed faster and faster. But take notice of broken figures. He begins to look for the second part of the figure again. Yes, he did. Yes, something like that. It seemed like Synesthesia saw the entire figure and followed its contour.
Well, Synesthesia made some mistakes during the test. However, these mistakes proved that she perceived the world differently. It seems that the experts had no doubt that she has synesthesia. Will the experts recognize such perception as phenomenal? We'll find out a bit later. Now let's meet the next participant of the program. Yevgeny Dubin has extremely sharp eyesight. However, he has never seen the importance of this ability, not in a shooting gallery where he proved to be the sharpest shooter, nor later when he served in the Army. However, when he began working with stereo images, an interesting phenomenon at the intersection of optics, physiology, and psychology, he noticed that even the slightest differences between images were not lost on him.
I suspect that probably the creation of these stereo images developed my intentional focusing. I used to do it spontaneously. Now I've started to control my ability. When I realized that I can control this process, I felt comfortable.
Yevgeny can see the differences between 2 very big and very small images within seconds. Despite the fact that his ability impresses the public, he doesn't consider his ability remarkable.
I think it's objective. Besides, in my opinion, well, I mean, I can teach this ability to anyone who really longs for it. I can teach anybody.
Such a modest estimation of his talents doesn't prevent Yevgeny from posing the following question to himself. How is a human eye able to notice such slight details and differences?
We'll offer you the following test. You'll see two identical images and you'll have to find differences within a period of time. Are you ready?
I'm ready.
Evgeny is looking at Whirlwind, a reproduction of the famous artwork by Russian painter Philippe Malevin. The original version is on the left. The modified version is on the right. However, Evgeny doesn't know that. He also doesn't know that the difference between the two images is in this tiny fragment. Both images are saturated not only in color, but also in details. Still, it took Evgeny about 20 seconds to find the difference.
What is the difference then?
There's this green spot here. Here,
Yes.
this spot is absent.
It's amazing how fast and faultlessly Evgeny coped with the task. But Whirlwind is just a warm-up. The experts prepared a new pair of images.
Well, not easy.
Our program is not interested in easy. However, frankly speaking, it should be mentioned that the reproduction of this work, Moving People, by Dutch painter Caroline Vies, is really difficult to perceive. Painted in abstract, impressionist style, it contains such a number of details that it seems impossible to catch them all. Almost a minute has passed, and Evgeny has no answer yet, probably because there's a trick in the pair of the images. The original reproduction is on the left. The image on the right is not only modified here in the middle part, but on the whole, it has less resolution. Will Evgeny notice?
Frankly speaking, I can't find, because the whole image looks like a big difference. It's difficult to call the images similar because there are some elements here which are outside of this image. This yellow spot is moving aside. They have different scales, and my method, unfortunately, isn't working correctly.
You're right that the images are different in size, but despite this, you can try to find the difference between elements which you have to cut out, figuratively speaking, this element from the left image and find the difference. I can tell you that the difference is here, in that part which you can see.
Aha.
Please try.
For the next 3 minutes, Evgeny honestly tried to distinguish the differences in the central parts of the images, but he couldn't find them. Actually, the experts already have a ready-made hypothesis why this happened. They'll share it with us a bit later.
Evgeny, to definitely make sure of your phenomenal ability, we'll ask you to do it a third time.
The work Blind Spots by famous American painter Jackson Pollock was chosen for the third pair of images. This image is very complex and extremely saturated with details. It seems that Evgeny feels uncomfortable. Indeed, he can't see any differences again. This is no accident. There's a trick in these images as well. But the experts prepared this task not just because they're cunning. They wanted to check their hypothesis and finally explain the nature of Evgeny's abilities.
I suppose this is a tiny spot again, right?
Obviously, our participant doesn't have even the slightest idea as to where the difference is hidden.
It seems you can't figure it out, correct?
It's quite very difficult.
Well, let's say that you can't find it.
Uh-huh.
That's it. Calm. Relax.
But I wonder where.
Relax. That's it. Are you with us? Listen to me. I intentionally provoked you having said that there was a small difference. There are no differences here. And you didn't find them. And you didn't find them. It was purely an experiment. I intentionally said so to persuade you that there are differences here. Well, so to speak. As a whole, the results are extremely interesting. In the test where the images were different in size and couldn't find it. That's correct. Because
No, as for the second image, when I already knew where it was located,
what did you feel?
what did I feel? Every difference is a small conflict. Both the left and the right images seem to break through somehow, try to go to the forefront, and it causes the conflict. There was a big conflict here, so
The detection of mistakes. I see.
even when I didn't know where the spot was located, if these images were really similar, then probably. Though it's hard to say, I would find it. Probably not at once, despite the fact that it's tiny.
Our hypothesis is that you overlay two images. Do you understand? So when the size was different, you couldn't overlay them at all. And you got lost.
Yes.
It's impossible, you know.
No, I couldn't.
In terms of overlaying, they're absolutely different. In terms of intellectual analysis, they're quite similar. We found all the differences much faster than you. We did it very fast because we did it differently. We don't overlay them. No, we don't. But our opinions differ. I think that you don't use your memory, but you see both images simultaneously. Yes, my colleagues think that you remember one image to some extent and overlay the first image with the second.
Well, the experts' opinions are divided. We'll see if they come to an agreement in the final discussion. Now it's time to meet the third participant. Edouard was born blind. However, this doesn't prevent him from orienting himself in any space. Whether closed or open, without a cane or a guide, Edouard manages this with the help of a phenomenal ability. He uses echolocation to move around. To be able to confidently move across any territory, he only needs to produce a specific sound.
Well, something like this. It can be regulated, made a bit higher or lower, but only a little bit. You won't hear it on the recording.
After Edouard makes this sound, he listens to its echo, how the sound reflects off of various surfaces. This reflected signal is an inexhaustible source of information for him. Edouard says the main thing is not to be too far from the objects.
The closer the better. Well, 2 to 4 meters. That's the average distance. That's echolocation for everyday life, but about 2 meters is perfect.
Thanks to echolocation, Edouard faultlessly identifies everything around him. He can say for sure whether the object near him is big or small, stone or metal, wood or plastic. Edouard can even correctly describe the dimensional characteristics of a person that he comes into contact with. Apparently, the only place this phenomenal ability fails him is modern shopping malls.
That's because there are a lot of glass structures there, and they resonate in a strange way. The sound splits. I can hear the return sound signaling that there is something on my left. Then it reflects off on my right, and I start thinking that the entrance is on my right, when in fact it is on my left. I have to orient myself using different prompts in this case.
Edouard, there are 3 experts here, and we have all heard a lot about your phenomenal abilities. In your opinion, what phenomenal things can you do?
I can orient myself with the help of the sound. That's not something phenomenal for me. It's more of a necessity. But most people around me consider it phenomenal.
We would like to ask you now to go from A to B and tell us what object you come across. These objects have been placed here randomly. We ask you not to touch them.
Of course.
So, Edouard will have to go through a mock labyrinth. You see, on his way, he'll come across objects of various materials, shapes, and dimensions. The choice of trajectory is not obvious. The objects are placed quite close to each other and really at random. Let's see if Edouard will manage to avoid all the obstacles in his way and get from A to B without any assistance or tricks, using only his phenomenal ability.
This is an object as well. I'll go around it. Okay. I think there is some wood here, probably. Well, not a tree, but something big. It starts somewhere here. Just a moment. Okay. I could go around it from a different side. Okay. There's no way out here. Or is there? Just a second. If I go around it like that, I've done that already. It doesn't make any sense. Okay. Wait a minute. Could I pass by here? I need to think it over.
The barrier tape obviously makes Edouard nervous. So far, he can't find its beginning or end. The situation is obviously unusual, but to get to the end, our participant will have to alter his strategy, change his path or motion, or show resourcefulness.
But maybe I could go around it somehow. Once again, I feel like there's something knocking around there, something like a tripod, I guess. Something really small. Well, it's almost impossible to hear. I need to think it over. Okay, someone.
Well, you're almost there.
Despite all the difficulties, Edouard brilliantly coped with the test. Not only did he pass through a most unusual labyrinth, but he also defined the objects around him quite correctly. And it took him only 6 minutes and 20 seconds. Out of this time, he spent 3 minutes developing a safe way to overcome the most difficult and unusual obstacle, the barrier tape. So that's a really wonderful result. Let's find out what our experts think.
We have a few questions. How do you yourself estimate your hearing? Is it better developed than other people's, or is it on the same level? Could you reproduce a tune? You'll hear it and reproduce it. Is that possible? So you have a regular good ear for music. Edouard, if we give you some objects, I think you'll manage to tell a table from an armchair, right?
Of course, sure.
Can you define the height of the ceiling?
Sure. Well, it's too high here, so it's...
Too high. How much is that? Compared to your height, for instance, what do you think? Could you count how many of your height, how many times we must multiply your height to get to the distance to the ceiling?
Okay, one time and one more time. And I guess some distance will be left.
Well, there was a barrier tape here. You couldn't pass because of the tape. It's just a broad adhesive tape, something like 12 centimeters wide.
It's too narrow, but it reacts to the wind.
Narrow, yes, reacts right, but it's hard to define. But you could have passed under it.
Well,
What was the difficulty?
I don't go under things as a rule because it's difficult.
That's good.
I was walking like that once and nearly fell off something. And I haven't got a cane here. And I understand there are people here and so on. But I've never done that, and I just won't do it.
That's understandable.
It seems the experts have collected information from all of our participants. Now it's time to decide who really has a phenomenal ability, whose extraordinary perception of the world is most interesting from a scientific point of view.
Okay, colleagues, let's discuss the results one by one. First, Synesthesia, a person with phenomenal abilities. Well, Anton, what do you think of her as a specialist? Well, I definitely support Synesthesia. Her ability is original, innate, and though there are quite a lot of people like her, the phenomenon is still there. And as a specialist, could you tell us how many people have the same abilities? From a demographic standpoint, 4% are synesthete, and only 1% have the same abilities as Synesthesia. Oh. That's 1 in 100. Yes. Well, that's a large sample, of course. Yes. This is a phenomenal ability, but quite widespread, so to speak. Yes, but the phenomenon itself is understudied. Well, I think this ability is amazing. Of course, ordinary people don't have it, but as Anton says, 1 in 100 still has this ability, so I don't think we could consider it super phenomenal. Even for a synesthete, the ability to recognize a coded figure is a phenomenal ability. Oh, that's important, right. As for Yevgeny, colleagues, what do you think? In my view, his case is quite unique, and there are two hypotheses here. We discussed them already. Anton thinks that, well, correct me if I'm mistaken, that's the convergence of two fields of vision. Convergence of two pictures at once. This really needs to be scientifically tested. This is interesting. Most importantly, this can be checked. A case for science, and this, it can be checked. It's possible. It can be tested in an experiment. To develop some experiments to find this out in that way, I think that he's the most interesting object of study for this topic. I mean, for phenomenal abilities. Yes, his ability to distinguish the smallest details in every picture where there are several hundreds of them. This is a phenomenal ability. And we did our best to misguide him. We tried to misguide him, yet didn't manage to at all. No, we didn't. No, I mean, whatever the mechanism, he discovered it himself. Yes, in any case, I've never heard of a visual system for people with such abilities. Okay, as for Edouard, yes, we think, I at least think, that this is quite widespread. Development. One human system develops at the expense of another, so to speak. If a person is blind, their sense of hearing is better developed. Compensation. Compensation. If a person is deaf by nature, they, on the contrary, develop. Absolutely right. Their sight, sense of smell. Of course, this ability is interesting, but in the context of other participants, I can't call it phenomenal. It's useful. Yes. I mean, among the blind, this ability is quite widespread. He only invented how to produce these sounds, sometimes to tap his cane. That's not always convenient, so he chose a sure frequency that stands out against the background of others' noises. Surely this means he's talented. Maybe he even has unique abilities, but they don't stand out. Well, there's nothing to study here from a scientific point of view, in my opinion. The mechanism is clear. Yes, Yevgeny for sure is very interesting. So, shall we choose Yevgeny? Sure, I agree. I think we all agree that Yevgeny is the most interesting. And some issues remain unsolved here. Possibilities. To study, to answer our questions. The issues that divided us. Sure, yes. Sure. Shall we make a supposition? There must be a supposition in science. I think, yes. To look for answers, otherwise there's nothing to look for.
So Yevgeny's ability has made our experts really curious. Pavel and Grigory think that Yevgeny manages to unusually quickly distinguish the slightest differences in two images, owing to his good memory, not eyesight. The experts reckon that looking at one image, he remembers it quickly and precisely. He then turns to the other image. He kind of overlays one over the other. Owing to this, he immediately sees all the differences. But don't forget that this is only a suspicion, and in order to confirm or refute it, we have invited Alexei Gusev, Doctor of Psychology, Professor in the Department of Psychology at Moscow State University, and an expert in the sphere of human perceptual psychology.
To estimate your abilities, we will use a standard psychological method which allows us to estimate the level of your ability to determine the slightest changes in visual stimulus. Press Next to start. If you notice a change, press Yes. If you don't, press No. And most importantly, remember that you'll see pairs of stimuli which are identical. Naturally, you won't see any change, and press No. Let's get started.
Despite its deceptive simplicity, this test will show us a lot. With its help, the sight of more than 300 volunteers has been studied at Moscow State University. They were all middle-aged and had good eyesight without any pathologies, just like Yevgeny. Their results are stored in program database, and we'll now see if Yevgeny's abilities are outstanding.
As you can see, the green bars are your results. They really exceed standard results by a lot. I mean, your results are the best, right? You didn't make any mistakes. You did simple tasks approximately on the same level as everybody else, but your results in difficult tasks and tasks of medium difficulty are much higher.
And we've moved on to the next test. Yevgeny will have to find a difference between two images of a tiger. However, our participant won't see them at the same time. The images will be given to him one after the other, and there will be one more image used in this test.
So you'll be shown a picture that you've already seen along with an abstract image.
Yes, I remember it.
The aim is very simple: to erase the retinal image from your short-term memory. You look at the picture of the tiger. Then the image is erased from your memory, and then you see the next picture of the tiger. These pictures differ in one small detail. You must be attentive, and after the images have changed, you have to say that you've seen the difference. If you're ready, we can start.
Let's get started. Got it.
You did this test quite quickly in 49 seconds. 49 seconds. Let's see what you've done. Show us what you see with your finger.
A black spot over the tiger's left eye.
Of course.
And the answer's right. Yevgeny managed to find differences in two images in 49 seconds. Is that a lot? Find out right now. Let's give this test to another 7 volunteers. They all have good eyesight and all are about the same age. They will have 3 minutes to do this task. Let's check if anyone will manage to repeat or beat Yevgeny's record.
Yevgeny, let's draw some conclusions. With the help of these methods, we study the most important functions of vision, such as concentration and working spatial memory. To this end, we used several standard methods. The first method worked very well. How do we estimate it? We compare your results in terms of accuracy and of the speed at which you looked for differences in these color squares. Your results are really high. You're one of those who performs this task almost without any mistakes and very quickly. You don't know this, but after you, we tested 7 people, volunteers we chose randomly. Only one person, Alexei, coped with the task and found the difference in 2 minutes, 55 seconds. 3 other people didn't manage to do it in 3 minutes. We set the time limit to 3 minutes. They didn't give them any suggestions as to where the differences were. The other 3 people gave wrong answers, false answers, several times in a row. So you belong to the small group of people who do these tasks quickly, accurately, and automatically.
Automatically? Do you mean on the subconscious level, or?
Yes, our visual perception is an unconscious process. We don't think about how we see something, we just see it.
But it took me some effort to find all this.
Of course it did. It took you some effort. I mean to say that you didn't control your working memory. You didn't tell your brain, your consciousness, I'll look over here first, then I'll look over there, I'll remember this information, then I'll retrieve it from my long-term memory. No. You did it absolutely naturally. That's why, what's the difference between you and the others? You managed to remember the first image in these 400 milliseconds, keep it in your memory, do the same with the second image, and compare them. In most people, this process is more obliterate, more loose, less reliable.
It seems Alexei's study findings confirm the supposition of our experts. Apparently, it is Yevgeny's unique memory that allows him to find slight differences between images so quickly and faultlessly. Of course, to make sure of this, we would need a whole series of pristine scientific experiments. But the fact is that 4 prominent scientists unanimously determined that Yevgeny has a phenomenal and interestingly natural ability. This adds another unique case to our program's collection.